So we have the following expression. We have the identity matrix. We add it to 2A. So A is a matrix. And then we take the inverse and we say it's equal to this 2 by 2 matrix. And the question is, well, how can we find A? So let's go through the steps and see how to do this. Okay, so let's work the details of this problem. So this is what we could do. As a first step, maybe we could change or just give an identifier to this matrix. Let's call it matrix B. So now I could work with variables of matrices. So I have the identity matrix. I add it to 2A. A is a matrix. The entire thing will be a matrix. We take its inverse, and it's equal to the B matrix. So I know the following identity, that if I have some matrix and I have the inverse of it, and if I take the inverse of an inverse of a matrix, well, this will get me the A matrix. So this is a useful property that I certainly can take advantage of in here. So this is a property of inverses. So let's just do that. So in fact, what we could do is we could just take the inverse here, and I would have to take the inverse here as well. So what this gives us is the following. Inverse and inverse cancels. So I will eventually get this expression. Identity plus 2A equals to B inverse. So now I have an identity matrix. I could get rid of the identity matrix. So I would have to add it by minus I here. And I would have to also do minus I on the right-hand side as well. And at this point, when you have this expression as such, well, what you will get is that the identity and the identity will cancel each other. And we're left with only the 2A on the left-hand side. So a scalar 2 multiplied by matrix A equals to B inverse minus the identity, like this. And in order to isolate for the matrix A, we could divide by scalar 2, and then we'll get that A is equal to 1 over 2 B inverse minus the identity. So this will help us find a value, a numerical value for the A matrix. This is the expression that we need to keep in mind when we will work the details of how we can find the A matrix. It's really this expression that we have to solve in order to find what the A matrix is. So let's give it a try. One key thing that we need to find is the inverse of the B matrix. We call this the B matrix. So if I find the inverse of it, so B inverse is equal minus 1, 4, 2, 5, and I want to find its inverse. In order to find the inverse of a 2 by 2, well, I need to find the determinant. So it's going to be 1 over the determinant multiplying the diagonal. So 5 times minus 1, so this becomes minus 5. Minus 2 times 4, well, this is 8. And then I have my matrix. I change the order between 5 and minus 1. So 5 goes on top, minus 1 in the bottom right side of the matrix. The 2 becomes a minus 2. The 4 becomes a minus 4. And now this is what I have. I could simplify this a bit more. So we have minus 8 minus 5. So this becomes minus 13. So minus 1 over 13. And then we multiply it by 5 minus 2 minus 4 and minus 1. So let's go ahead and do this multiplication. And we get minus 5 over 13 in here. And then we get 2 over 13 here. And then we get 4 over 13 in here. And then we get 1 over 13 for this last entry. So this gives us some value for the B inverse matrix. So we got this, and this is a good step in order to find what the A matrix is. So the next step would be to essentially take this B inverse. So we could, in fact, just go ahead and try to solve it for the A matrix. The A matrix is equal to 1 over 2. We take the B inverse matrix, which is this, minus 5 over 13, 2 over 13, 4 over 13, 1 over 13, and we subtract it by the identity. The identity must be a 2 by 2 because otherwise subtraction would not work. So this must be a 2 by 2. That's why I wrote the sub 2 here, which means that it's a 2 by 2. This also, the B inverse is a 2 by 2, and they multiplied by a scalar will give us a result. The A matrix will also be a 2 by 2. So we'll have a 1 in the main diagonals, 1, 0, 0, 1, like this. And let's see what this gives us. So we have a half, and then we have essentially, well, 1 is the same thing as saying 13 over 13, right? So every time you see a 1, you could think about it as 13 over 13 so that we could do the subtraction. So we do minus 5 minus 13. So this becomes minus 18. Minus 18 over 13. Here we have 2 over 13 minus 0, which is 2 over 13. Here we have 4 over 13 minus 0, which is 4 over 13. And then here we have 1 over 13 minus 13 over 13. So 1 minus 13. So minus 13 plus 1, this becomes minus 12 over 13. And this is what we got. At this point, we could divide by 2. And this will give us the following matrix. So 18 divided by 2, this becomes 9. So we have minus 9 over 13. 2 divided by 2, well, this becomes 1 over 13. And then we have 4 divided by 2. This becomes 2 over 13. And then we have minus 12 divided by 2. This becomes minus 6 over 13. So this is the result that we got for the A matrix. So let's just highlight it. And of course, it's always good practice, if you have time, to verify if your answer is indeed correct. And how do you do that? Well, you could just verify by solving it in the original expression, left-hand side, right-hand side, and see if you get the result that was originally given to you in the problem. And we will do that on the next slide just to see and just to show if indeed the result that we got for the A matrix is correct. So now we want to verify if the result that we obtained is indeed correct. So what we obtained was this. So for the A matrix, after doing the analysis, we got minus 9 over 13, 1 over 13, 2 over 13, and then minus 6 over 13. So in order to find to verify if this result is indeed correct, what we could do is we could look at the left-hand side and the right-hand side. So this is my left-hand side, and this would be the right-hand side. And we want to verify if we start from the left-hand side, do we reach the right-hand side? So let's give it a try. So left-hand side is equal to identity plus 2A inverse. A is a 2 by 2 matrix multiplied by identity, but multiplied by a scalar 2, so it remains a 2 by 2. So this has to be a 2 by 2. This identity has to be a 2 by 2. We take the inverse, the result should be a 2 by 2, which is shown here. So let's just apply the steps and see if we get indeed this result. So we will we have an identity of a 2 by 2 identity. So we have main ones in the diagonal. So 1, 0, 0, 1. We add 2 times the A matrix. If I have this and I multiply it by 2, what will it happen? What happens? So every entry of the A matrix I multiply by 2. So minus 9 becomes a minus 18 over 13. A 1 becomes a 2 over 13. A 2 over 13 becomes a 4 over 13. A minus 6 becomes a minus 12 over 13. So this is what I have. In the entire thing, we find the inverse of the entire thing. So now I could maybe just get the result of this addition. So identity plus this matrix that we got. So 1 is the same thing as saying 13 over 13, right? So we do 13 minus 18. So this becomes a minus 5 over 13 for the first entry. The next one would be 0 plus 2 over 13, which is just a 2 over 13. The next one would be a 0 plus 4 over 13, which is just 4 over 13. The next one would be 1, which is basically a 13 over 13. So essentially we do 13 minus 12, so this becomes a 1 over 13 in here. And this is the result that we got. We take its inverse, and then we see what this gives us. So the inverse of this matrix would be as follows. We need to find its determinant. So the determinant will be as follows. So it's 1 over the determinant of this matrix. So it is minus 5 over 13 times 1 over 13 minus 2 over 13 times 4 over 13. Like this. And then we multiply it by 1 over 13 here, minus 5 over 13 here, minus 2 over 13 here, and minus 4 over 13 here. So this is what we have. We could try to somehow simplify this expression. So this would be minus 5. And then we have minus 8, like this, over 13 squared. So on the numerator, we have minus 5 minus 8. So this becomes minus 13 over 13 squared. And in fact, this becomes simply minus 1 over 13. And we do 1 over this. So in other words, we simply, all of this reduces to minus 13. So what we get is the following. We get that the scalar outside the matrix is simply minus 13 multiplied by the matrix, which is 1 over 13 minus 2 over 13 minus 4 over 13 and minus 5 over 13. So now we multiply each entry by minus 13, and what do we notice that we get? Well, minus 13 times 1 over 13, well, this is just a minus 1. Minus 13 times minus 2 over 13, it becomes simply 2. Minus 13 times minus 4 over 13, well, it becomes simply 4. And then we have minus 13 times minus 5 over 13, well, it simply becomes a 5. And if you notice, this is exactly what we have on the right-hand side. So this is exactly what we have on the right-hand side here. Minus 1, a 2, a 4, and a 5. And so therefore, this is a justification that our analysis is indeed correct, and the result that we got is indeed correct. This is the proof for it here. This completes the video. Thank you for your attention.